Okay, so in the previous tutorial we have completed animation montages section. So if I quickly demo you what we have currently, so we can play animation montages even while we are moving or even as a full body, right? Okay, so now we can look into a new feature which is aiming offset. For example, let's say if we have sort of a rifle that has been equipped, maybe when I'm looking up, the character should look into up as well, and when I'm looking down, the character should look down as well, right? So we have sort of a feedback from the character animations based on our camera manipulations, right? Okay, so in order to start with, first I think these three components would be enough, so I'll close the rest of the tabs, and then we can implement a new data structure within our data table, right? So currently we have this general category to implement sort of shared procedures across multiple different movement groups. For example, we have jump, sprint, leans, and idle stances. So I think similarly we can have sort of a general data structure here which stands for aim offsets, right? So I'll go to the structs, locomotion, and inside the general category I'll create a new blueprint structure called aim offset. Okay, and then let's open up the data structure and I'll add several fields. So obviously we need aim offset, which is the type of aim offset blend space, right? And we need yaw range, which is vector 2D, and we need pitch range, again vector 2D, and we need some offset range as well, again vector 2D, and interpolation speed, this is a float, and blend name, type of name, and finally blend weight, which is a float, right? So as default values, I will give the yaw range as minus 180 to 180, and the pitch range as minus 90 to 90, and rest of the stuffs I can keep it as it is, right? Okay, and then let's assign this to general category and a new field called offset. This should be as an aim offset. Okay, so since we done structural change, make sure not to click save all at once, right? Because we have to resolve each and every child instances properly before moving towards the parent targets, right? So first I save this one SNM general, then SNM general has been used at SNM set, so you can see the structure is now broken, right? Okay, so potentially the issue comes since we made a major change at this general category, right? But that would be fine since we have a backup of our DT and set. we can reassign this. This should be a denim general. Right? Okay, now this anim set is good to go. And let's go to the dt anim set. Save it. And let's see whether we have lost the existing data. It seems yes. You can see like the general category doesn't have any sort of values, but that's fine. Since we have a backup, we can quickly reinstantiate those stuff. Right. So I made this change to here. We are good to go. So let's go to the data table and I'll re-import. Right. So let's click re-import and I'll select this one. And these warnings would be fine actually. Yeah. You can ignore those stuff and simply click OK. Right. So let's quickly look into the existing configurations and field values. Okay, so the aim offset is empty, which is expected. Walk is there, and yeah, it seems okay. Right. Okay, so we have this aim offset here at the general category. Now we should have a way to read those stuff at our ABP locomotion, right? So I'll move it to the ABP locomotion, and so these are the general stuff that we were focusing on. So I'll add a new pin here and I'll simply copy the general struct and paste it here. So what we are interested in the aim offset, so I'll keep it like this and let's break the pins. Right, let's expand it. Right, and then let's promote this to a variable. I'll call it as aim offset. This should go under anim sequences. Now plug it to here. And now before implementing any other stuff, I will collapse the existing nodes and call it as aim offset. Aim offset, yeah. Let's go inside the collapse node. And then I'll promote each of them in two variables. This one is your range. This one is its range. And this one is interrupt speed, but I'll mark it as aim offset interrupt speed. And this one I'll rename it as similarly aim offset blend name. And this one also need to be promoted. Call this as aiming offset. This one aim offset blend weight. Okay, so let's organize the pins. Right, okay, And then so this aiming offset range should be initialized at here. That would be fine, right? So since we are not going to override any sort of stuff, we can keep the aiming offset, but I think we need to check the anim validity of this aim offset, right? To check whether we have a valid aim offset or not before playing it, right? So I think we have a section called set aim anim validity, and there actually we check for cardinal validities and jump validities. So similarly, let's add a new pin and simply let's test for aim offset is valid. If it is valid, let's promote this to a variable called is valid aim offset. And I'll add the pin to here and add the reroute node like this. Add a comment called aim offset validities. Okay. And this one we can move to anim validities category. Right, so now we have a way of reading aim offset at our anim instance, which is ABP locomotion. So now let's implement the aim offset logic at our anim graph. Okay, so at the anim graph, I'll create a new animation layer actually called what? Maybe we can simply say full body aiming. Okay, and this full body aiming should have an input pose. So therefore I'll select this animation layer and click on the inputs, and as the input, maybe I'll give it a name called pre-pose, right? Previous pose that we have. And for now I will simply connect it to here, compile and save. And let's go to the let's go to our anim graph. And where do I need to call this thing? Right, so after the montage slots I will use montage pose cache and use this full body aiming, and I'll promote this to a new cache pose called aiming pose cache. Right, and I'll make a comment called aim of set. Right, and then instead of the montage pose cache, now we can use this aiming pose cache. Okay, and let's go inside the full body aiming and let's start implementing it. Right, so as usual I will first save this. I will break this link and save this to a cache pose called pre-aim pose, right? And then I need to calculate the aim pose, right? But in order to calculate the aim pose, I need to determine the aim yaw and the aim pitch that I currently have. So in order to do that, I think we need the function to be implemented at our blueprint thread safe update animation. So I'll create a new function called update aiming data, make it as a thread safe, and inside the blueprint thread safe aiming data, yeah, I can plug this thing maybe at here, right after the root offset. I will plug this update aiming data, and I'll move this to blueprint thread safe functions category. And I think as the input pin, we need the delta time as usual, which is a float. Okay. So inside this function, yeah, do we have, yeah, we have this stuff at here. So I will use aim offset interp speed, and since this is a frame specific interpolation, I will promote this to a local variable called local interp speed. So make sure to use local variable, otherwise it will be using the global variable where this one is not resetting at each frame, right? Because this is a set animation data pre-configured value. But either way it would be fine, right? Since this is a static value. But in case later on, if you need much more dynamic features, capabilities, make sure to promote this to a local variable instead. Okay. Right. Now let's calculate the aim pitch first, right? So I'll promote this to a new variable called aim pitch, which is a float, and get it to here. And let's use this existing aim pitch to interpolate for a specific target pitch, right? As delta time, I can use the existing delta time. As the interp speed, I can use this local interp speed, right? But we need a way to determine this target value, right? But for now, I will keep it as 0. And similar implementation we need for the aim yo. So I'll add a new variable called aim yo, add it to here, and I'll use the aim yo, same interpolation for a specific target value, and it will set the aim yo. Okay. Now we need to calculate the target value that we are going to use. But this needs certain calculations to be done accordingly. It will take some time. So since this video is going to be too long, I will cut it here as the first part, and the second part I will show you how to calculate this target aim pitch and target aim yo. I'll see you there. Thank you.